Hi everyone, Shania here. Today I'll be going over my circuit and code for my debris vacuum circuit design, and I have named my robot the Leaf-Lugger, but essentially it is a robot that cleans up debris from leftover yard work, so leaves or sticks. So to get into the circuit, I'll just be walking through the wiring and components on this Arduino circuit. So the brain of this circuit is the Arduino Uno. As we can see, it's connected to the USB port, and the role is to receive sensors to send controls over to the motor driver. For input components, we have two main input components connected to the Arduino. We have our HC-SR04 ultrasonic sensors. This blue module in the ultrasonic distance sensor is pretty important for my robot since it detects obstacle avoidance, so larger leaves or sticks that might clog the robot, and it uses 4 pins, as we can see here. It is, see if I can zoom in a little bit. We have our VCC, our GND for ground, our trig for trigger, and echo for receive, and VCC is for power. The trig pin is connected by a red wire, and the echo pin is connected by the orange wire. And are wired to two of the Arduino's digital pins, so 12 and 11. 12 and 11. And to measure the time, it takes about the sound pulse to return for calculating the distance. And then we have our TCR T5000 IR sensor array. Um, this is used for line following purposes, so the black sensors on the board detect the difference between the dark line and light surface, and the output pins are connected by the orange, purple, and black wires, which feed into the digital slash analog pins. And then for the power and control, so the motor system, we have a 9-volt battery, and the 9-volt battery is used to provide the necessary power for backup if solar is not available. And it is connected with the positive terminals connected by the red wire, and the negative terminals connected by the black wire. And the motor driver, so the amplifier, the black rectangular chip, so here the L298 L298N is an H-bridge motor driver that I use for the 9-volt battery positive and negative terminals to connect directly to the inputs. And then for the wheels, I have two motors here, the two DC gear motors. The two yellow motors at the bottom here are the main source of power for the robot's wheels. And then one servo motor right here is often used for precision, which this robot does need, and it is wired directly to the PVM cable digital pin on the Arduino. So for simulation purposes, this is what the simulation looks like, and then getting into my code. So here's a brief overview of the code. And this is a solar power code is for the solar power debris collecting robot. And basically the code checks whether if the solar panel is sending enough voltage to run the system, and it measures using the analog pin on the Arduino. If the solar voltage is above 3 units, the robot automatically runs on solar power, and if it doesn't have enough, it will go back on the 9-volt battery. And basically the code informs the user that the robot is now running off of stored energy instead of solar energy. And the vacuum motor sucks up the debris is controlled by a single pin connected to the transistor or the relay. And the motor runs on both solar and battery power. So if it doesn't have either or, kind of relays on the other option, but no matter what, there is an active power source to allow the system to efficiently operate during the day while still having backup power. Thank you for watching.